Okay, kiddos, this is question number 3 from Tuesday's assignment. That's Graphing Rational Functions 1. And we are going to first simplify this function as much as we can. So I'm going to factor the top and the bottom. There's nothing to factor on top, but there is something to factor on the bottom. So this is x plus 3, and the bottom factors to x plus 3 and x minus 2. You'll notice that that means we have a common factor, x plus 3. I'm just going to note that down here. I cancel out that common factor, and then I write my simplified function. And so because the whole x plus 3 on the top went away, that's 1 over x minus 2. Now, because I had a common factor, I'm going to have a whole. And the first thing I do is find the whole. I set the x plus 3 equal to 0, which means x is negative 3. Now a whole is a point, it is not a line, and so you need to find a y coordinate as well, and you do that by plugging this x value into your simplified equation. So our y value is negative 1/5, and our whole is at negative 3, negative 1/5. Once we have found the whole, we can move on to our vertical asymptote. And we find the vertical asymptote by setting the bottom equal to 0. So x minus 2 is equal to 0. Notice I've gone back to my simplified function. You have to go back to the simplified function to do this, otherwise you're going to mess it up. Okay? If x minus 2 is equal to 0, my vertical asymptote is at x equals 2. After we find our vertical asymptote, then we're going to look into our horizontal asymptotes. We find that by comparing the exponent on the top of the function to the exponent on the bottom of the function. Our exponent on top, you may notice that there's just a 1. Because there isn't an x there, the exponent is 0. And then on bottom, there is an x, and so that's got an exponent of 1. The bottom is bigger, and that means that our horizontal asymptote is 0. After we find our horizontal asymptote, then we go ahead and find our x-intercept, and you find that by setting your top equal to 0. And my top here is just 1, so I set that equal to 0. And when I do that, I get 1 equals 0. And so here's the question, does 1 equal 0? No, it does not. All right, that means there isn't an x-intercept. We do want to note that on our paper so that we remember and don't accidentally graph one or something. All right, the last thing we're going to find is the y-intercept. And we find that by plugging 0 into our function and then solving for y. So I've got y equals, and I'm going to use the simplified function again, 1 over 0 minus 2, which is negative 1/2. And so my y-intercept is 0, negative 1/2. And what we do at this point, guys, is that we graph all of those things. So I'm going to move the paper down so that you can just see this stuff, and we'll graph it a little below, okay? Do you want to make your graphs nice and big and pretty? I'm trying to save a little space here. Okay, I'll graph my whole first. It's at negative 3, 1/5. And again, that doesn't have to be super accurate. It needs to be between 0 and 1. Oh, it's negative 1/5, guys. Good thing I'm using a pencil. Right down there, -1/5. Okay, between 0 and -1, closer to 0 than -1. I have a vertical asymptote at +2. I have a horizontal asymptote at 0. I'm going to draw that right above the x-axis just so that it doesn't blend in with my x-axis. And no x-intercept, which makes sense because we have a horizontal asymptote at 0. I've got a y-intercept at 0, -1/2. And so this graph goes through those 2 points, and then there's another piece over here. Now I know that this is what this graph looks like. You guys, of course, would plug it into your calculator and make sure that you've got your curves in the right place. The last thing that you need to do is you need to identify domain and range. So the domain of this function is -∞ to -3, because there's a hole there, right there in -3. -3 to 2, because of the vertical asymptote, and then 2 to infinity. And the range is -∞ to -1/5 because of the hole, -1/5 to 0, 0 because of the asymptote, and then 0 to infinity. And that is number 3 from Tuesday's assignment, again, graphing rational functions, number 1.